The masking threshold is of a triangular form which decreases with 27 dBs per bar for the lower slope, and a slope that depends on the pressure level and the center frequency in the band we are considering for the upper slope. An approximation of the minimum masking within a critical band can be made using this figure here. Masking at the upper frequency Fu of I in the critical band I is responsible for masking the quantization noise with approximately 32 dB using the lower masking threshold that decreases 27 dB per bar. The upper slope has a steepness which depends on the sound pressure level, and this steepness is lower than the steepness of the lower slope. Masking across critical bands is presented this figure here. The masking signal in critical band I-1 is responsible for masking the quantization noise in critical band I, as well as the masking signal in critical band I. This kind of masking across critical bands further reduces the number of quantization steps within critical bands. Here we also see the spread of masking due to the nonlinearity of auditory filters, and the resulting masking threshold is the sum of power of neighboring spreading functions. And we see that we have a lower slope that is equal to 27 dB per bar and an upper slope that is given by this equation here. And we see that there is this interference of these two spreading functions when we consider masking of neighboring bands.